I'm starting off with basically the steps for solving. I think it's really important that you know what the procedure is for solving, especially when we have lots of different types of equations. So that way you have something to follow when you're going through your notes and everything like that. So just to clarify here, so an absolute value equation, so absolute values are those vertical bars. So you have vertical bars equal to a number. And the way this works is that we always split up so there's two equations to solve. So basically, we set up one equation where I'm going to just write inside. Whatever the inside is equal to the number, and you solve that equation. And then you also solve where the inside is equal to the negative of the number. And we do this because the absolute value makes things positive. So you could have a positive inside there. You can also have a negative inside there. So there's two possibilities of what can be inside the absolute value. So because of that, we have two equations to solve in order to find both possibilities. So I'm also going to use the highlighter here to kind of color code. So whatever's on the inside of the absolute value goes on the left side. And then what is outside the absolute value goes on the right side, either the positive version or the negative version. Now, in order to use the rule where you split it up into two separate equations, you have to get the absolute value by itself first. So that's the first thing you do, is you have to get the part with the absolute value, that whole thing by itself. Then you create your two equations, and then you solve. So you are going to end up solving linear equations like we were doing at the beginning of this, and last week we were doing some solving of linear equations. We're adding a couple steps here, basically. So before I actually start solving, there are 4 different forms or types that these can take. So you can have something inside an absolute value, and if it equals a positive number, you're going to get 2 answers, because the absolute value makes things positive, and you could either have a positive or a negative in there, it still will be positive. If you have your absolute value equal to 0, there's only one answer because there's no plus or minus 0. 0 doesn't have a negative. It's not really positive. It has no sign. So there's only one possible equation to write there. I'm going to actually go to the bottom here to the no solutions. So if you have your absolute value equal to a negative, there are no solutions because the absolute value is always positive. So if you get an absolute value equals a negative, you have an impossible situation that it will never give you a negative out. So that's no solution. And then there are some forms where you have an absolute value equal to another absolute value. And when you solve those, you just ignore one set of the absolute values and then solve like normal. So usually in something like that, we ignore the set on the right and pretend those don't exist, and then we solve. So all of these, the number of solutions you're going to get depends on what it looks like after you get the absolute value by itself. So you're going to want to pay attention to that. And notice that if it's equal to 0 or it's equal to a negative, that those are sort of special cases, and you're going to have one or no solution. So let's actually get to the solving, because that's the important part here. So I've got 2 different problems here. These are both relatively quick, not a lot of steps, so that's why I put them on the same thing here. So I'm going to do the one on the left. So our goal is to get the absolute value by itself. So I want this absolute value of A to be by itself, just like if you wanted A by itself or a variable X by itself. So it's the same idea. So we're going to solve that like we solve when we have something without an absolute value. So even though it has these symbols, you're treating it the same as you would solving a problem without the symbols. So don't let those absolute values freak you out. So we need to get that absolute value of A by itself. So I need to add the 15 to the right side. So that is going to be the first step. So on the left, I have the absolute value of A. And then on the right, I have 23 plus 15, which is 38. So we've got the absolute value by itself, and it's equal to a positive number. So that means we're going to have two answers. So once you have this value equal to a number, and I will highlight it the same way I highlighted before, the same color, so you can kind of see the pattern there. So we have an absolute value equal to a positive number, so we're going to create two equations from here, because A could be 38, or A could be a negative 38. If you have negative 38 inside there, you still get a positive 38 out. So what we do, I always write arrows here, is you take what's inside the absolute value, so without the symbols, and then you set it equal to the right side, so A is equal to 38. And then you take the inside and you set it equal to the negative of what's on the outside, negative 38. So we have two answers here that work in this equation, 38 and negative 38. And that's simple enough to see at the step above before I did the arrows, because I'm saying, okay, what can I plug in for A that will give me 38 out after I take the absolute value? So it's either a positive or negative 38. Both will give me positive 38 out. So that's the basic structure here that we're solving. So I'm going to move on to the problem on the right, and we're going to follow the same sort of structure. I need to get the absolute value of B by itself. So just like if I was solving for B without the absolute value symbols, I need to move the 10, and then I'm going to have to divide by the negative 2. So when you first start out, you're just treating it like you would solve for any variable, and you don't really think about those absolute value symbols. They're just symbols there. So the first thing is going to be to subtract 10 from both sides. So that gives me a negative 2 with an absolute value of B. And I always make sure to try to make my lines as straight as possible so that they don't look like parentheses. So when you're taking notes, you're going to want to make sure that your absolute values are straight, your parentheses are curved. And I try to make them taller than my numbers and letters so that they don't look like ones. So you got to be very careful about how you write them so that it doesn't get confusing. And then on the right, I have negative 16 minus 10, so that is negative 26. So again, I want to get this absolute value part by itself. Now, a lot of people are prone to say, oh, I can just multiply that negative 2 through absolute values. You can't do that because the absolute values don't act like parentheses. Distributing does not work or does not exist for absolute values. It's something different. So you do want to be very careful that you don't treat it like a parenthesis because they're not. They're very different. So your goal is to get the absolute value portion by itself, what I have in yellow. So you're going to divide both sides by negative 2 because I need to get rid of that negative 2 that's in front. So let's switch colors here. So I'm going to divide both sides by negative 2. And that gives me the absolute value of B equals, and then we have a negative 26 divided by a negative 2, which comes out to a positive 13. So now we have our absolute value B equals 13. And then once you get that absolute value by itself, that's where you want to write your two separate equations. So you take your inside, which is B, you set it equal to the outside, which is 13. And then your second equation, you take your inside, and it's equal to the negative of the outside. So you get negative 13. So we've got the absolute value, the inside, which is B, and that gets two equations, and then the outside here, which is 13, also comes with the two equations, but one is a positive version and one is a negative version. And this gives us two answers. So if I plugged negative 13 in to the absolute values, the absolute value of negative 13 is a positive 13. It makes everything positive. And if I plugged a positive in, I would still get a positive out. So here's another example. I've got the absolute value of 3x plus 2 equals 7. So we have the absolute value part by itself already. So it's already by itself. So I can go straight to the two separate equations here. And again, I'm going to color code so that you can follow the same sort of pattern. So I've got my absolute value by itself, so I'm writing two equations. One with the inside, 3x plus 2 equals the outside. So we have 3x plus 2 equals 7. And then the other one, where we have the inside, 3x plus 2 equal to the outside, but a negative version, so that equals negative 7. So I get a 7 and then a negative 7 that these are equal to. But the inside is the same. The left side is the same. So we get two separate equations, and they both have 3x plus 2. Now we have two linear equations, and you're going to solve these for x to get your answers. And we're not going to get the same number as an answer, just a positive and a negative version. So what you noticed here is we got the same number, just a positive or a negative. That is not going to happen here because it's not just an x inside of the absolute values, but because we have other things inside the absolute values. So we're going to get two different answers that work here. So I'm going to start by solving the one on the left. So I'm solving for x. So I have 3x plus 2. I want to subtract 2 from both sides. And you may notice that that's the same thing as the second equation. I would also, first step would be subtracting 2. So I usually just go and do it all at the same time because it's the same step. The only thing that's different is what's on the right side. So 3x plus 2 minus 2, those cancel. So I'm left with just 3x. And then 7 minus 2 is 5. Now on the right, the 2 minus 2, that cancels. I still have my 3x, but I get a different number on the right because of the negative 7. Negative 7 minus 2 is negative 9. So we get two equations that are almost the same, but not quite. So we're still solving for x. And I have a 3x, so that's 3 times x, so I want to divide by 3. And because these equations both have 3x, both of them I'm going to be dividing by 3. So you can see that there's really a pattern. It's just what changes are the actual numbers on the right, but the steps are basically the same. So 3 divided by 3 is 1, so I'm just left with the 1x. And then I get 5/3, so I have a fraction here. So that's going to be 5/3. Now on the right equation, I have 3 divided by 3, so that's 1, so I have 1x equals, and negative 9 divided by 3 is a negative 3. So I get a whole number here. So I have two answers. 5/3 and negative 3. And these both work in the equation. And you can check your answers. And it's always good practice to check to make sure that you didn't make any mistakes. So let's see, checking the fraction one, I have the absolute value of 3 times x. So x is 5/3. Then I have plus 2 equals 7. So 3 times 5/3, though that cancels and I'm left with 5. So I end up with 5 plus 2 in the absolute values, which is 7. So I end up with the absolute value of 7 equals 7. And that is true because the absolute value of 7 is 7. So I got a true statement. That equation works. I do get 7 equals 7. So now let's check the second answer we have to make sure it works. So I've got the absolute value of 3, and then I'm times -3, because that's 3 times x. So I put parentheses around it because it's negative. I don't want it to look like a subtraction. Then we have plus 2 equals 7. So I'm going to simplify the left side. Inside the absolute value is 3 times -3 is -9. So I have -9 plus 2 inside the absolute values. -9 plus 2 is -7. And the absolute value of -7 is a positive 7. So I get 7 equals 7. The equation is true. So I have a true statement out there, so that equation, that answer works. Now I have our situation where we have the two absolute values. And so when you have something like this, where you have an absolute value equals an absolute value, you ignore one set of the absolute values, and we usually ignore the one on the right. So we're going to look at this equation as if it's the absolute value of -x plus 4 equals 3x minus 8. So we're going to just ignore one set of the absolute values in order to solve this. So we've got the absolute value by itself. So we want to write our two equations because we already have it by itself. Once you get that absolute value by itself, that's what you do. You write your two equations. So here it's a little more complicated because we don't have just a number on the right. We have an expression. We have 3x minus 8. So it's a little more complicated, but it's not really as bad as you might be thinking. So first off, you always start with the inside of the absolute value. So we have -x plus 4. And then your first equation is always whatever is equal to the right side. So that one's easy enough. I have -x plus 4 equals 3x minus 8. The second equation, you still take your inside, -x plus 4, but now you're setting it equal to the negative of the outside. Now the outside is more than one thing, so I'm going to put this in parentheses. I didn't need to do that when I had just a number that it was equal to. But if it's equal to more than one thing, I'm taking the negative, and I'm taking the negative of everything that's on that outside part. So I have to have it in parentheses. So just to color code, our inside is -x plus 4, so that stays the same. And if you just pay attention to the colors, I have the inside equal to the outside, and then the inside equal to the negative of the outside. So you see that the pattern is the same, even though I had to add those parentheses, because I have more than one thing there. I have the 3x minus 8. So I'm going to solve each of these for x. And I don't want the colors to confuse you now. We're just solving like normal. And I'm going to actually treat these two equations slightly different because of the fact that I have to distribute a negative on the equation on the right, but not the left. So these are complicated enough that I'm going to do one equation at a time. So I'm going to just do the left one. And it doesn't matter what side I put my x on. I can move my x to the left, I can move my x to the right, but we usually put the x on the left. So I'm going to do that, and I'm going to do that by subtracting 3x. So I just always move my x's first before I add move the numbers, so that way I can make sure my x's are where they are before I do anything else. That's just what I always do. So I have a negative x minus 3x. So that's negative 1 minus 3, which is negative 4. So I have a negative 4x plus 4, then 3x minus 3 is 0, so I don't need to write that. And then I have this equal to negative 8. So now that I have my x on one side, I need to move that plus 4. So I'm going to subtract 4 from both sides. And notice how I'm kind of using colors here. So I did have that video about taking notes that I emailed out and how you can take notes in math. And when I'm teaching, I don't write my teaching notes the same way I would if I was actually taking notes. But I am still using colors. And I'm using the same color for when I'm adding or subtracting things from both sides, because those are it's the same step that I'm doing. And then you may notice that I used a different color for the dividing. So I'm kind of color coding here so that you can see that I'm using the same rules. So the subtraction property of equality is what allows me to subtract from both sides, or the addition property would allow me to add on both sides. So in this case, I'm subtracting from both sides twice, so I use the same color. When you take notes, whatever works for you, but this is how I do it. So I'm left with negative 4x, the 4 minus 4 is 0, and then negative 8 minus 4 is negative 12. So now I have a negative 4 times x, so I need to divide by negative 4. So a negative 4 divided by negative 4 is a positive 1, so that's 1x, so I just have x. And then negative 12 divided by negative 4 is a positive 3. So I have x equals 3. So now I'm going to work on the second equation. So I did the first one. You can see it took several steps. Now I'm going to solve this one. And the first thing that I need to do here is distribute. I need to distribute this negative through the parentheses. So if it helps to put a negative 1 there to remind that you're multiplying by negative 1, you can do that. So I need to multiply the negative 1 by the 3x and by the negative 8 there. So we have an extra step because of that negative in front. So the left is still negative x plus 4. And then I have a negative 1 times 3, so that's negative 3, and then the x. Then a negative 1 times a negative 8 is a positive 8. So I'm negative 3x plus 8. So you can see that the numbers are the same, but the signs are opposite from what I had in the first equation. So now I'm going to move my x to the left like I did before, but notice that all of the signs are going to be opposite in this case, because now I have a negative 3x, so now I'm going to add 3x to both sides. So a negative 1x plus 3 is the same as 3 minus 1, and that gives us a 2. So we get 2x plus 4 equals 8. Because negative 3 plus 3 is 0. So now I have a very different equation that I did with the left equation, and that's because we have these extra x's and other things in there, and then the minus decided it changed things quite a bit. So there's no shortcuts when you're solving an absolute value equation. You can't just solve 1/2 and then say the other answer must be -3. It doesn't work. So there's no shortcuts. You have to solve both types of equations, both sides. So I've got 2x plus 4 equals 8. So I need to move the 4. So I'm going to subtract 4 from both sides. So we get 2x equals, and then 8 minus 4 is 4. So 2x equals 4. Now I need to divide both sides by 2 because I have a 2 times an x in front. So 2 divided by 2 is 1, so I'm left with x. 4 divided by 2 is 2, so my second answer is x equals 2. So we have two answers, 3 and 2. Sometimes, if depending on how the system wants you to write these answers, sometimes we write them in curly braces with comma there in between them, just to indicate that there's two answers. This is it's more of like whatever the homework system decides it wants you to answer them in. I don't remember what Alex does. I would have to log in to see some systems, because I've used many different systems. I've used Alex, Connect Math, My Math Lab. We've got WebAssign, Wiley Plus. There's tons of different math systems out there. Some of them you don't need to put the curly braces. Some of them they give you the curly braces already. Some you just write in the numbers with commas. So pay attention to what they give you and how the system, works. Maybe take a look at the examples so you can see how they write it. Because there's not really a rule for how you're supposed to write these. It's more of what's easier on the system. So you could see these written various different ways when you're solving. And if you want to check your answer, you need to check your answer in the original. So if you're going to check here, unfortunately, that is not a very orange. It's supposed to be orange. But you're going to check your answers in that original problem. So let's just check one of them. So let's say I wanted to check x equals 3. So I would have to plug it into both sides here. So I have negative x, so that'd be -3 plus 4, and then close the absolute value. And then on the right, absolute value 3 times 3 minus 8. So when you're checking something like this, it has to go into both sides if that's where your x is. So I need to simplify the left. -3 plus 4 is 1, so that's absolute value of 1. And then on the right, 3 times 3 is 9, so we get an absolute value of 9 minus 8. And because I'm trying to smush my ones and my absolute values are looking very similar. So you can see this is why I try to make them look taller. So we end up with the absolute value of 1 equals the absolute value of 1. So that's a true statement. And so that works. And then if you checked 2, you would also end up with a true statement. I don't really have room to check that, but it would work out. I didn't make any errors here that I see. So these were all the examples that I had planned. At this point, do you guys have certain things that you need help on? Are there issues with Alex that you're running into? Are there other topics from this week that you need some extra help on? You can turn on your mic or you can chat in the chat box. But I have time to do some more examples, kind of show you some things in Alex if you're having trouble. I want to make sure that if you guys are running into issues that I fix that before we get too far in. So shoot away if you have other things. Lauren says the polynomials are tripping you up. So I moved my keyboard now. So I moved it out of the way so I can use my stylus. Let me log in. Is it the factoring or is it the operations that are tripping you up there?
I think it's the operations.
Okay, so like the adding, subtracting,
Right.
multiplying. Okay. Which one? Is it all three of those, adding, subtracting, multiplying, or is it just one or?
I think it's more so whenever they combine them, like they'll have it to where it'll be P exponent 4 times Q exponent 7 over P exponent 5.
Ah, okay. So that is part of the exponential expressions. So if there's no plus or minus in the system or in the problem, then that's considered an exponential expression.
Oh, okay.
If there's plus or minuses, then it's considered a polynomial, basically. So yeah, good thing to know, right?
Yeah.
Let me pull up. The first few on the homework are just understanding, making sure that you understand the rules. Here is one, very similar. Oh, I should have opened this up in a different system. Okay. So I opened up Alex and then I'm in as a student. What I'm going to do is take a screenshot of the example problem it gave me, and then I'm going to paste it into OneNote, and then I'll share my screen so that you guys can have that. So that way I can just email out like the PDF or something. So it's going to give me a moment while I take all these screenshots and paste it in and then share the screen again. So many screens. I have 3 monitors, so that's also keeping track of what is on what monitor. It's pretty crazy. Okay, now. All right, so this is the problem that it gave me. It just randomly picks different numbers and everything for you. So we've got p squared times q over p to the 6th times q to the negative 2. So I'm going to just rewrite this to the right so I can just mark up all over it. So when we're simplifying these things, we sort of still follow the order of operations where you want to do any multiplication first and then any addition and subtraction. So as far as, so if I write down the order of operations, PEMDAS, when it comes to exponents, the multiplication of exponents would be under, like if you have an exponent on top of an exponent. So if I have something squared and then it's squared again. So that would be where you would be multiplying exponents. So we don't have anything here. So we wouldn't really be doing any multiplication. There's not really any dividing of exponents that happen until we start getting to square roots. And that's next week, so you don't have to worry about that here. So next is addition and subtraction of exponents. And addition of exponents happens if they're on the same level, so they're both on the top or they're both on the bottom, and they have the same letters. In this case, we don't have anything like that. All of our same letters are not on the same level of the fraction. So that means we're going to be using the subtraction property, where you subtract the exponents, and that's when you have them on different sides of the fraction. So we're going to subtract things that match by the base. So the base is what's under the exponent. So we've got a base of p, so those match up. And then we've got a base of q. So those are going to be what you're going to be subtracting. And you're going to be subtracting the exponents. If there is something without an exponent, you can write that in. You can add an exponent of 1, because anything without an exponent always assumes to have an exponent of 1. We usually don't bother writing the 1 unless we have to. Like, we don't write the 1 in front of 1x. We write it when we need it. Otherwise, we leave it off. So I wrote it in, so now everything has an exponent. And now our rule is that you subtract, you go top minus bottom for your exponents. So I usually do this in my head, but I'm going to actually write it out so that you have that for your notes. So for P, it'd be 2 minus 6 as the exponent. And then for Q, it's 1 minus negative 2. And this is usually where people mess up because you're subtracting a negative. So once I'm going to write that out, I'm going to now do the subtraction. So 2 minus 6 is negative 4. So P has an exponent of negative 4 now. Then Q, 1 minus negative 2 is the same as 1 plus 2. So that's going to have an exponent of 3. Now, the problem says to write it with positive exponents only, and I have a negative exponent here. We generally never keep negative exponents in an answer unless you're in calculus, because usually in calculus the negative exponent is useful. So we're not in calculus, so we're not going to keep it in that form. We're not going to keep the negative exponent. So I need to do something with this p to the negative 4. So this is where we use the rule that if it has a negative exponent, to get rid of the negative, you take the reciprocal. So I'm only taking the reciprocal of what has the negative exponent, so only what I've highlighted here in blue. So the q, I'm not touching that. The q to the third, nothing's happening there. I'm only dealing with the p. So if it helps, you can even write that first and then write it with your multiplication there, just to show we're only doing the reciprocal of the negative exponent. So that's 1 over p to the 4th. That's what allows us to get rid of the negative. Then we want to combine it into one fraction, and anything that's not a fraction automatically goes on top. So our final answer is q to the 3rd over p to the 4th. And so once you've got no more negative exponents, we only have one of each letter, that is how you know that you're done, basically. Yeah, question 4, this is a good one too. And of course, you guys are going to have different numbers, different exponents. So here we've got multiple things going on. We've got the whole thing to the negative 2 exponent. And then inside there, we also have more negative exponents, and it's, got a whole bunch of things going on. So if my outside has a negative exponent, or if there's anything here in parentheses with another exponent, the first thing that I do is always distribute that exponent through. So if we go back to the order of operations, this would be where you'd be multiplying exponents. Or we're doing the exponent part, and the rule is that you multiply them. So this negative 2, it applies to the negative 4. It gets applied to the exponent of negative 4. It gets applied to the 5 exponent on the y, and it gets applied to the z. So everything inside the parentheses, every variable, every number gets that exponent. So I'm going to start by rewriting this with a little more space. And so the -4 gets the exponent of -2. X to the -4 gets the exponent of -2. Y to the 5th gets the exponent of -2. And then Z gets the exponent of -2. So that outside exponent gets distributed to every exponent or everything in the inside, even if there is no exponent on it. And whenever you have a number, you include the negative. If there's a negative in a number, you just stick those together. So now you're going to simplify, and this is where you multiply your exponents, because we need to multiply these exponents together and these exponents together, because if you have an exponent on another exponent, they get multiplied. So I'm going to just start with my -4 to the -2 and just keep that the same for now. So on the x, I'm going to have a -4 times the -2, which is an 8. So that's going to give me 8x to the 8th. And for the y, 5 times -2 is -10. So that's going to be y to the -10. And then the z will just get that exponent of -2, because you can treat it like there's a 1 there. 1 times -2 is -2. So now everything with a negative exponent, I'm going to take the reciprocal of, because again, we want positive exponents only. So I'm going to be taking the reciprocal here, here, and here. So the only thing I'm not doing anything with is the x to the 8th. So I'm going to first write these all in fraction form. And then every negative exponent becomes positive when you take that reciprocal. I guess I don't need parentheses there. So the y to the -10, that becomes y to the 10. And then the z to the -2 becomes z to the +2. So now everything with a positive exponent goes on, or everything that's not a fraction goes on top. All the fractions go on the bottom. So we end up with x to the 8th over -4 squared y to the 10th z squared. And then the last step here is to actually do the -4 squared. So -4 times -4 is a +16. So our final answer is x to the 8th over 16 y to the 10th z squared. And I always put a line in the middle of my z's so they don't look like 2's. If you're somebody that has messy handwriting, I recommend working on it so that you don't confuse yourself and get problems wrong because you can't read your handwriting. I've seen that happen where people misread their handwriting and then put in the wrong numbers.